So we're getting into 5.2 today. And you guys already got these strategies down in your notes, I hope. I want to talk through a couple other things, but before I do, again, I just got to stress that this is going to be challenging. This is going to be kind of like if you think back to geometry when you had to do proofs. Although you guys were online geometry, so you didn't have maybe the same experience, but like a lot of students, you know, especially students who excel at algebra 1, they get to geometry and they're like, what do you mean there's no step-by-step? Like, tell me what to do first, tell me what to do next. And then they get really frustrated when like, well, every problem's different. And I understand that. I also need you guys to know that I have been doing these proofs for a really long time. Okay, so I need you to be aware that when you see me kind of thinking through this stuff, you can't expect that you're gonna end up being able to move through these things as quickly as I do. Okay, like it's just not a reasonable expectation. Over time, you're going to develop a sense for like, oh, you're going to spot these little things like, oh, this looks like some place where I could do that whole reciprocal thing. But at first, you're going to find yourself trying some things. Oh, this isn't working. You'll try something else. This isn't working either. I'll put a star next to it and we'll go over it in class the next day. And that's okay. Okay, you're going to get better at these. We're going to spend some time. We'll keep practicing them right up until the test. The other thing I want to tell you is that when we do get to our test, and these will end up on the test, it's always, I will always give you a set of proofs, but you only have to complete a small portion of them. So last year's test, I think I gave 4 proofs. There were like 2 sets of proofs. So I gave 2 proofs. You have to complete one of these 2 proofs. And here's another 2 proofs. You complete one of these 2 proofs. And my reasoning for that is I know sometimes you start it and you get stuck. So that gives you like, you say you start the first one, you get stuck halfway through. Well, I'll try the other one. Okay. So it gives you an opportunity like to not just like only earn half the credit because you got stuck on it. So, and that usually my students end up doing really well on the proofs. Those who are actually trying. So give it a go. Be ready to have a little bit of frustration and make some mistakes, but it's going to be all right. You guys got this. All right, so I'm going to give you some general strategies, but these are not hard and fast rules. This is not a step-by-step. In general, what we're going to see when we do this is, well, let me start with the format. Let me show you what these are going to look like. Our proofs that we're going to be doing here are going to be in a format that's going to look like this. And I don't need you to write this down because you're going to see examples of this, but I just wanted to kind of show you a general idea. Instead of the problem saying, take this expression and simplify it, it's going to say, take this expression and turn it into this expression. Okay, they're going to ask you to prove that this identity is equal. So your job is going to be a lot like what we did last time. Last time I just gave you one of these things and said, get it as simple as you can. Now I'm going to say, start here, make it look like this. Your work's going to look a lot like it though. You're going to start with that, with one side of it, and you're going to slowly make changes to that thing over the course of several steps. And then eventually, instead of just arriving at the simplest possible thing, you need to arrive at what I ask you to arrive at. Okay, so in some ways, this is a little bit easier than what you guys did on the homework because you know what the end result is going to be. On the homework, you didn't know whether it was going to end up being secant or it was going to end up being 1 or something like that. On this, you're going to know what the final step is going to look like. So that gives you a bit of a target. Same rules apply. 1 category of identity per step. Make your steps clear. And in general, if you're unsure whether you should include a step or skip it, include it. Okay, you'll lose points on the test if you're making too big of jumps in between steps. All right, so when I say start on the easier side, you're going to end up with some identities, and I'll just show you one that we're going to do today. I don't want to show you the whole proof for it, but this is one of the identities that we're going to prove today. And when I say start on the easier side, when I look at these 2 sides of this identity, this one looks easier to me than this. This one has fractions in it. It's got stuff inside of the fractions. This is everything's being multiplied together. We want to start on the more complicated side. I would start with this, and then I would try and make this look like this. In general, you want to start on the more complicated side and move towards the simpler. So that's what I mean by work from the more complicated side. When you're looking for complicated, addition and subtraction is more complicated than multiplication when it comes to this. If you see a side with addition and subtraction on it and a side that doesn't, I'd probably start on the side with addition subtraction. Any kind of messy fractions, that's more complicated. Start on that side. It's usually easier to start with a complicated thing and make it simpler than the other way around. All right, so then it's just some general things to look out for. Adding fractions to get a common denominator. We saw that on Monday. Factoring, I didn't talk to you about that one, but that was number 15 that we just went over from last homework, right? Look for a common factor, or difference of squares is going to come up a lot too. So if you see a difference of squares that can be factored, try that as well. Use this identity, which is basically difference of squares in reverse, to set up Pythagoreans. We're going to see a couple examples of that today. And then if you do have fractions, try and get a monomial denominator. Do you know what I mean by monomial? One term. In other words, no pluses or minuses in the denominator. Try and get it so that you've got a bunch of stuff being multiplied together and not a bunch of stuff being added or subtracted. Okay, that's usually gonna get you on the right track. Be mindful of your target. So as you're working, right? Let me go back to my little format page here. So I got a lot of pages of notes. We're not going to do all these today. As you're working through, let's say I started on the purple side. I need to keep my eye on this over here because this is what I'm trying to get to. Don't just be doing random stuff over here. Be thinking about like, okay, I need to somehow get a tangent or whatever this is. So what are some ways that I can move towards that? So be mindful of that as you go. And then a couple things to do if you get stuck. If I get stuck, one of the first things I'm going to look to do is turn the entire thing into sines and cosines. Everything can be turned into a sine or a cosine, right? Tangent is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, cosecant is 1 over sine. So try doing that. Another way is to try working the other side, and we'll see an example today where we'll kind of work both sides and sort of meet in the middle and then piece those two things together to make a viable proof. And above all, remember that all attempts leading to dead ends are valuable experiences. In other words, you're going to get stuck on some of these, but that's okay. That's how you're going to learn, okay? You're going to get stuck. You're going to stare at it a little while. You're going to try a couple of things and you're just going to be stuck. And then you're going to talk to a classmate or you're going to come in and ask a question. And when you figure out like what your next step is going to be, that's where the learning is going to happen. You'll be like, oh yeah, I could have done that. And that's going to stick in your brain. And the next time you run into a situation that's similar to that, you're going to remember that. Okay. That's only going to work for you though if you can't give up on the second step. You got to try these. All right, you guys ready to do this? It's going to be awesome. You're going to love it. Eventually you'll love it. Trust me. Trust me. All right, you all got your sheets out and ready to go? Let's do our first proof together. It's going to be great. All right, this is going in your notes, wherever you want to put them in your notes. We are going to prove that the tangent of x plus the cotangent of x is equal to the secant of x times the cosecant of x. So the first thing I got to do is figure out where I'm going to start. Which one of these sides of this thing do I want to use as my starting point, and which one do I want to use as my target? So as I look at these two things, my hard-gained wisdom, right? My experience has taught me that addition and subtraction are more complicated to deal with than multiplication when it comes to these types of things. So I am thinking right now, I definitely want to start with the left-hand side. This is more complicated because it has addition and subtraction. So that's what I'm going to do. So I'm going to start by setting this up. We always write down that side that we're going to start with. That's going to go off to the left. And this is where I told you last class, I'm going to be insistent that you follow the format. All of our steps are going to go down the page here with equals. So all of our work's going to be here. And eventually, I don't know how far down here, we're going to have equals secant x, cosecant x, and then we'll be done. All right, so what are y'all thinking? Tangent and cotangent. Sines and cosines, use those quotient ones. You want? Yeah, for sure. Should we do them both? All right, so tangent is sine over cosine. Cotangent is cosine over sine. Are we getting to the point where when we think tangent, like we're like immediately sine over cosine? Cotangents, cosine over sine. Awesome. Okay, now it's all sines and cosines. That's good. I think that's a good first step. Looking up here, we're trying to get secant times cosecant. This has got a plus in it. We don't want it to eventually have a plus in it. Ideas. Common denominator, was that one of our strategies? We talked about that even last time. We got two fractions, maybe we could combine them together into a single fraction. Let's try that. Let's try and get a common denominator and then we can try and combine them together. So I'm going to rewrite this. I'm going to leave some space after each of my fractions to include my fancy magical ones. I'm color coding this for the sake of our notes. And then try and think to yourself, what fancy version of 1 could you multiply each of those by so that we ended up getting the same denominator? Looks like we will eventually need both a sine and a cosine in our denominator for both fractions. I'm thinking for this one, I might do sine x over sine x. I'm thinking for this one, I got the sine, but I need the cosine, so I'll do a cosine x over cosine x. And just double checking, that is going to give me sine x and a cosine and x in both denominators. So we should be able to put those together into one big fraction with cosine x and sine x in the bottom. And what are we going to have in the numerator? Sine x times sine x, that's sine squared x plus cosine squared. Ooh. Sine squared plus cosine squared, guys. That's exciting. That's 1, isn't it? All right. 1 over cosine x sine x. Okay, that was exciting. I need to keep my eye on the prize though here. What are we going for? I'm going for secant and cosecant. Oh, you want to split this up into 2 fractions? So that is the advantage of trying to get a common denominator so that things are multiplying, is that you can split them up. So I think that's great. Yeah, let's split it up into 2 fractions. So that is 1 over cosine x times 1 over sine x. And I think does that get us there? Yeah. That is secant and cosecant, isn't it? Hey, all right. Secant x times cosecant x. Oh, wow, this is easy, isn't it? Answer is no, it's not. Okay. I've done this problem a lot, so I kind of knew the next step. I knew the guiding questions to ask you, even though you all were thinking about it, right? I'm not going to be standing there next to you while you're doing the homework asking you those guiding questions. So it is going to be tougher, right? But you get the idea how it works, right? One step at a time, slow but sure, we get to the end. And then we get to the end, yeah. And then there's this thing in math, QED. Anybody ever heard this before? QED, that they do after proofs? Anybody want to look that up and come back and tell us what that means next? It's like a mathematical mic drop. It's like boom, there you go, you're welcome, kind of. QED, all right, let's keep going. Let's do a ridiculously hard one next. What do you think? Yeah. This one says do chew first. I think we'll do chew first. Okay. Oh, this is a great one. We have enough space here. These do take up quite a bit of space. Just for reference, a lot of my students in the past, they get annoyed that they can only fit sometimes one problem on a page. So a lot of them will actually turn their pages sideways and do one proof on this column and one proof on this column. So they'll go landscape mode with their paper and then like divide it into 2 columns so they can fit 2 proofs onto the same page instead of one. I do want to see, I know that some of you love cramming all your homework onto one piece of paper. It's not going to work out for this. I want to see them going down the page like this on your homework, because that's how you're going to do it on your test. Okay. Write small and make columns. Okay. Here we go. Proof number 2. This is a really good one. We're going to prove that cosine of x over 1 minus sine of x is equal to 1 plus sine of x over cosine x. So, and this is why I look at this, I'm like, yeah, we're not too sure. Is not a very evident one. If you were to ask me whether I believe that was true, I'd be like 50-50 chance there. Fancy version of 1 is, so you've got some instincts going already. Fancy version of 1. I'll tell you, your instinct is right. We're gonna. Oh wait. Isn't, well, good question. Is 1 minus sine cosine? No, 1 minus sine squared is cosine. Like, you're thinking about that. All right, before we get into, I love that you guys are already thinking steps, but remember, we got to choose which side we're going to work from first. Okay. So let's decide what we're going to work from before we start throwing out strategies. But it's awesome that you're already thinking strategies. And I'm hearing some instincts that are going to serve you well. Okay, so when I look at these 2 things, it is clear to me that one of these is definitely more complicated than the other, even though they look very similar. And again, this is just from my experience. Whenever I've got addition or subtraction in a fraction and it's in the denominator, that's complicated. Okay, I know that I want to start with this left-hand side, even though they both contain fractions, even though they both have addition or subtraction in the fraction. The fact that this one's in the denominator makes it significantly more complicated than this one in my eyes. Okay, this one's a little easier. I could split it up into 2 fractions and do lots of stuff with it. I'm gonna start with this one though, because it's more complicated. So let me get my left-hand side set up here. Cosine x over 1 minus sine x equals. I don't know if I got enough space for this, but that's all right. All right, so we cannot split this up into 2 fractions. That would be a common misconception that somebody might say, isn't that cosine over 1 minus cosine over sine? That doesn't work when it's if it had been flipped around, we could do that. We could have split this one up into 2 fractions, but not when the addition or subtraction's in the denominator. So I know I've got an inkling about how to get this going. I'm curious what your thoughts are. So we're thinking about a fancy version of 1 again, and you said multiply it by 1 minus sine x over 1 minus sine x. Let's just play that out for a bit in our mind. You're going to end up squaring this then, right? Remember, when you square a binomial, you get the first thing squared and the last thing squared, but you also get that middle term. We're going to end up with 1 squared and sine squared, which I like because that's kind of like our Pythagorean, but we're also going to end up with a plus 2 sine x in here. Okay. You sound like you don't believe me, but let me just remind you of this, okay? I love where you're thinking about this. We're just going to modify it slightly. If you do a plus b times a plus b, if you go through the whole FOIL process, you are going to end up with a squared and you are going to end up with b squared, but you're also going to get ab and another ab here, right? So you're going to end up with this 2ab as well. In our case, that's going to end up being a 2 sine x. So yes, we are going to end up with a 1 and a sine squared, which is cool with the whole Pythagorean, but we are also going to be stuck with this. I'm going to modify it slightly. Okay, there's one small thing change that I would like you to make to your fancy version of 1. So instinct is right on track. We're going to multiply this by a fancy version of 1. And your suggestion was 1 minus sine squared x over 1 minus sine squared x. We're going to do 1 plus sine x over 1 plus sine x. That's going to get rid of that middle term. On your strategies sheet, when you guys wrote down your strategies, that's this thing right here. We already had the a minus b. I'm going to multiply it by the a plus b, and that's going to get me that a squared minus b squared. So I love your thinking, your instincts are right on track, but we're actually going to multiply it by it. This is kind of like a conjugate. Now, look up here for a second before you go on, because I see some of you already jumping into the next step. Look up here. I know what the bottom is going to turn into. It's going to turn into 1 minus sine squared. Go ahead and write that down if you haven't already. And then look back up here because this is important. I got a multi. You guys ready? Hang on. I got a couple people still writing. I don't want you to miss this. I'm going to have to multiply this cosine x times the 1 plus sine x. My thinking right now is, do I go ahead and multiply it times both terms and write it as cosine plus cosine sine? Or do I leave this cosine alone and just have this 1 plus sine x in parentheses in my next step? Just have it in parentheses. Why is that the better way to express it? So this is what I was saying. Always keep your mind on what we're going for, right? I would not want to multiply this cosine into the 1 plus sine x because I will need a 1 plus sine x in my final answer, don't I? So let's leave the 1 plus sine x as it is, and we'll leave the cosine x separate from it. Do you guys get what I'm saying here? Rather than distribute, which I could have done in that same step, I'm choosing to leave the 1 plus sine x there because I know I need that in my final answer. All right, let's see if we can keep going here. So that whole purpose of doing that was to turn this into 1 minus sine squared x, and I'm thinking that's one of our Pythagoreans, isn't it? Couldn't we take this and turn, if we subtracted sine x from both sides, we would end up with cosine squared equal 1 minus sine squared. So would you agree that this is cosine squared on the bottom? It is cosine squared on the bottom. So, oh, and then we're going to have some canceling. And I love it when you get to the point where you're writing a step down and you're already starting to think about what the next step's going to look like. That's usually the place where I start like writing things incorrectly though. So be careful. I start getting excited and then like I leave off a square or some, change a plus into a minus, and then I get stuck 2 steps later. So be careful about that. But totally, we got a cosine up here. This is a factor. So we can't cancel it with one of these cosines, which is also a factor. Now I don't even need those parentheses anymore. And, oh, that's it. I was about to say, let's look back at the original and see how we're doing. And I'd say we're doing pretty darn good because that's what we're going for. Okay, super duper. How you guys feeling? All right, keep in mind, we're doing this as a group now. This is going to be a little bit more challenging when you're doing it on your own, and that's going to be all right. I mentioned this last class. If you've got a study group, this is a great unit to be working with like a buddy or a small group on your homework assignments, because you're going to have ideas that you can kind of bounce off of each other. Hey, why don't you try doing this and I'll try doing this and we'll see which one works better. All right. How are we doing for time? Oh, should we do this one? Yeah, it's massive. It's massive. Maybe if you've got less than half a piece of paper, you might want to start a new piece of paper. And I'll warn you, I might quit halfway through this because I do want to make sure we see the last one. We spent some good quality time going over homework questions. So I'm already hearing some ideas about how we can tackle it. Don't forget, the first thing we need to do is figure out where we're going to start. And I'm hoping that everybody's on the same page with this one. I told you complicated in these cases means addition and subtraction and messy fractions. And I got one side that's got a whole bunch of both. This looks easy to me. Multiplication, whew, that's easy. Let's start on this side. So as we were getting started, I heard some ideas. I heard some fancy versions of one. What other instincts are you having about this? Work towards Pythagorean. Work towards some Pythagorean. Let's remind ourselves, what's the Pythagorean that's got the secant in it? Tangent squared plus 1 equals secant squared. So I'm actually thinking about secant squared minus 1 is equal to tangent squared. That might be useful to us. I'm pretty sure I can do that for both of these by multiplying by that. The other thing I'm thinking about is we got two fractions being added together. What's something that is usually a good idea when you do that? Get a common denominator and turn it into a single fraction. And I think actually we can accomplish two of those things at one time, right? So I think that's going to be my first step with this is get a common denominator, right? Because when I look at this, this is going to need this factor to make it a common denominator, and this one's going to need this one. And I think that common denominator is going to end up multiplying together. It's, I don't know. Let's see how it goes. I'm thinking too many steps ahead. Leaving some space here for my fancy ones. So do you see how if I multiplied by this same thing, but with a plus instead of a minus, that would get me secant squared minus 1? And that's our Pythagorean. That's what I'm going to do here. And then same thing over here, except this one's got the plus. I'm going to multiply it by secant minus 1. And as I'm looking at this, isn't that also going to accomplish getting a common denominator? Aren't these both going to end up being the same denominator down here? So I'm going to go ahead and turn it into a big old common denominator. Hi. Thank you. Whenever you says as soon as possible. So got this on record so you can cut up later. Say again. I would say so. We only got like 12 minutes left. Secant squared x minus 1. What's going to be on the top here? We got a secant x plus 1 times 1. That's just secant x plus 1, and then plus secant x minus 1. Ooh, this is not exactly what I was hoping for. Well, kind of. The ones are going to cancel, right? And then we got 2 secant. Oh, there's the 2. We wanted a 2 in our answer, right? That's good. So that would be 2 secant x on the top, and then I'm going to go ahead and do my Pythagorean on the bottom. I didn't use an identity or anything on the top. I'm just combining like terms. Secant squared minus 1 we said was tangent squared, right? Oh, I think we are in good shape here. I think I'm feeling pretty strong. We need cotangent, cosecant. Oh, I like that idea. Turn the tangent into a sine over cosine. And I'm going to go ahead and do this along with my, remember I showed you how you can turn, instead of dividing by a fraction, you can multiply by its reciprocal. I'm going to do this in the same step. So tangent is sine over cosine, right? But I'm now multiplying it, so I'm going to do the reciprocal of that. It's going to end up being cosine over sine. Now this is kind of, if you're not sure about that step, we could break that down into 2 secant x times tangent. Well, it would be 1 over tangent squared x, which is cotangent, which is this. So this is a little iffy going from here to here. If you guys are okay with it, I'm okay with it. Did you have a question? The 2 secant x, because when I looked up here, I had 2 secant x's being added together. So this is like 1 secant x plus 1 secant x gave me 2 secant x's. And then these ones went away because of the opposite signs. I was kind of hoping these would go away too, but alas. We good? Where are we going next? This is looking less and less promising. Well, I don't know. What do you guys think? Should we turn secant into 1 over cosine? Do you think that'd be helpful? Thinking ahead, that would allow us to cancel one of these up here. You want to try it? When in doubt, turn everything into sines and cosines. I'm just leaving it out in front because I need the 2 in my final answer, right? So I'm just leaving it out in the front. And this is going to cancel with one of these. So that's just going to be 2. So this is just going to end up being cosine x over sine squared x. I'm trying to get cotangent, cosecant. Oh, I see it. Split this up into 2 fractions. I'm going to split this up into the sine squared x on the bottom. I'm going to split it into 2 fractions. And then I just want one of these to be 1 and 1 to be cosine. Look at what we're trying to get, which I can't show on my screen right now. We want cotangent to come first and cosecant to come next. I think we can make that happen, right? What do I want this first one to be? The 1 or the cosine? Cosine. And this would be the 1. Yeah, this is cotangent and this is secant, and we're there. Woo! Q, E, D. No, you don't have to write QED. You're not allowed to write QED until you look up what it stands for. It's Latin. No, not on your phone. All right, one more. I got to show you this last one, and I got to show you kind of quick, okay? Because we only got 7 minutes. That one was a messy one. I debated whether to even show that one to you because I don't want you to get disheartened. You're going to run into maybe 1 or 2 on your homework that are that messy, but chances are we're going to be going over those ones, okay? All right, last one here. Cotangent squared x over 1 plus cosecant x is equal to the cotangent of x times secant x minus tangent x. This one is actually worked out in your book. I think it's the last example or second to last example in 5.2. And this is the reason I want to go over this is an example of where sometimes you get stuck working it and you end up trying the other side and sort of meet in the middle. That's how I would have accomplished doing this proof. Okay. So when I looked at this at first, I said left-hand side definitely more complicated. It's got fractions in it. Fractions got addition in it. So that's where I started. I started with cotangent squared x over 1 plus cosecant x. And I'm going to I'm going to move you through this one a little bit faster. Okay. So this is my thought process, but it's not, trust me, it took me longer to do this than it's going to take me to go over it. Cotangent squared, I looked at that and I was like, square, that could be a Pythagorean. Look at your Pythagorean identities. Is there a cotangent squared? Could it be helpful to us? Oh, it involves cosecant, doesn't it? Cotangent squared. Cotangent squared, check this out. Cotangent squared is equal to cosecant minus 1, isn't it? So I'm going to do that because what that accomplishes is I now have all of my trig functions are the same. I like that. The other reason I want to go over this is this next step. I know that when I see two things that are perfect squares with a minus in between them, sometimes it's good to factor them as a difference of squares. And in this case, it's going to be very good to factor this as a difference of squares. Cosecant squared minus 1 is going to turn into two binomials. One of them is going to have a plus and one of them is going to have a minus, right? It's going to be cosecant x plus 1 and cosecant x minus 1. And I just know because I've seen enough problems where that was helpful that I tried it. I don't think it was my first instinct, but I got there eventually. Do you see why that's helpful to us? No, because look how beautiful this is. Cosecant x plus 1 and cosecant x plus 1. These two things are going to cancel. Well, and that's the big question. So that gets us to here. And the question is, how am I going to get from here to here? And that's where I stalled. Okay. Like, how am I going to turn this into this? Now that's where I got stuck. So here's what I did. Out of my margins, I started working this side over here. I was like, what if I could mess around with this and get it to match up with this? Then I could just take those same steps and reverse them and finish up this proof. Okay, so I looked at this and I was like, what can I do with this? Cotangent, secant, tangent. How about turn it all into sines and cosines? Cotangent is cosine x over sine x. Secant is 1 over cosine x. Tangent is sine x over cosine x. And this is all just going on scratch paper, right? This is not part of my proof. What am I going to get if I distribute this in here? What's going to happen to these cosines when I multiply these two things together? It's just going to turn into 1 over sine. This first one's going to just be 1 over sine, isn't it? I might be skipping too many steps here. Let me write it out. This is going to end up being cosine x over sine x cosine x minus, and then cosine sine over cosine sine. I'm just distributing here. I mean, it's messy distribution, but I'm just distributing. Do you see the cosines canceling? Where? It's the sine. I've left my x off. Cosines are going to cancel. We got 1 over sine x minus everything cancels here. That's 1. Oh, okay. And that is cosecant x minus 1. So I have in your textbook. So have a look at that. Folks, you are going to have questions on the homework. Homework's on Canvas. I want to see that you've at least tried a few steps into each of these problems, okay? Don't stall out. Write the first step down and say, I'm done. I want you to try something. You got this. It's going to be awesome.